Now, hand over to Alba. That's here. And the pointer is there.
Hello. Hi. Okay. Hi, I am Oriol Vallcorba from Alba Synchrotron in Barcelona, the Spanish synchrotron. And well, I'm from the controls group, and I will show you our steps at Alba towards adopting the fair data management principles. I am only a small part of this work. There is a lot of colleagues involved, so I will speak on behalf of all of them. Okay, here it is the outline of the talk. I will start with a small summary of the current status of the fair implementation at Alba, some of the challenges that we are encountering during the process of implementing these principles, some words on the design and implementation from the data collection up to the data catalog, and finally some remarks and considerations. So let's start. Here you can see a few key points of the current data policy at Alba. Okay, so the users don't need to copy data home. It is restrained for during a minimum period of 5 years. There is an embargo period of 3 years. Afterwards, it will become publicly available. And the high-level metadata are visible right after the experiment. Okay, at Alba, we are adopting the ESRF solution of the data catalog, the solution that is developed in the ESRF, the data portal, sorry. Up to now, the users were accessing their data via SFTP or bringing their own disks to take the data home. And now with this catalog, they can access the data from anywhere and browse it. Also, as Marjolaine showed in the talk, there are other integrated tools in the data catalog, such as the e-logbook, that they can take notes during the experiment, and also automated messages from the control system. Also, there is some data visualizers and tools for specific techniques, such as, for example, the macromolecular crystallography, where you can see the process data as well when it will be implemented. Also, we are assigning a DOI to the experiments, but it also can be assigned to individual subset of data sets. And the data will be available in some open data portals to be accessed from anywhere. Okay, let's see now the current status of the implementation at Alba. Now we have 12 beamlines in operation and 2 in advanced phase of construction. So up to now, we have only 1 beamline that is fully integrated in ICAT. Okay, this is LOREA beamline, angle resolved photoemission spectroscopy beamline. And but we have 5 beamlines that are in the testing phase. Let's say that we are publishing already to an ICAT database that is in testing. So we hope that this will go into the production database by the end of this year. And with the experience that we are gathering with these beamlines, we hope that shortly after, during the next year, we may be able to have all the beamlines or most of our beamlines in the data catalog, publishing the metadata in the data catalog. Okay, I will show now some of the challenges we are encountering. This project is a project that spans multiple, as we are organized at Alba, it spans multiple sections of the computing division. So in this sense, we need to transfer information between different software systems and within ourselves. And the solutions that we are implementing, we need to find a way, if something fails, know exactly where it fails and how it fails and why. For this, we adopted some techniques and some ways to do the work. So we are, let's say, not alone. We have some international collaboration and some inputs from the community. We implemented some project tracking tools. We are doing regular follow-ups with all the teams of the project, but then we are also doing small working groups for specific tasks. We try to avoid overlapping ourselves, identifying clearly the boundaries of each group, define clearly the APIs between ourselves, and of course, try to document everything as much as we can. Okay, besides the coordination with ourselves, let's say, there is very important the coordination with the scientists. This, for me, is quite critical because we need to balance the FAIR requirements with the existing workflows that they may have on the pipelines, trying to minimize the interference with their work and not give them additional workload. So we need to be very clear on the benefits that this will be for the final users and from the scientists themselves. We need to get from them also instrumentation context and the software they are using to exploit the data. Then we identify relevant metadata that we need to publish in ICAT, especially the one that we want to be searchable, findable. And since there are different beamlines with different techniques, we try to standardize as much as we can the solutions to have a better maintainability. Finally, we also need to coordinate with the users because from them we need the sample descriptions to put in the metadata. And for this, we also need to facilitate tools before, during, and after the experiment. Okay, let's now see a little bit about how we implemented this. I will speak about from the beamline instrument up to the data portal. So here we are collecting the data and its associated metadata, and there is a first layer that is the control system. In Alba, we are using Tango as our control system. And here we have the SCADA framework that is Sardana, but also we are using other frameworks like MXCube, or maybe we can have other proprietary solutions, other type of ways to collect the data. So we decided this to store the metadata in a Redis database using streams that they may contain, depending on the beamline, if we are collecting already Nexus files in these techniques that are application definition compliant. So then we may point only to a path of the Nexus file and some other basic information of the proposal, but otherwise we may be able to extend this information on the Redis stream with other type of metadata from different places of the beamline. So how we do this? So we have, for example, a Sardana, preferably. We are using a Sardana plugin for this, that it's publishing directly this metadata to the Redis device, to the Redis database. But we also have a Tango device for this that we may use as well. We have Sardana or directly from other devices. There are other specific solutions. For example, MXCube, they have a LIMS hardware object for ICAT, so we may publish directly to the data portal from here. It's still not implemented. We are exploring this solution. If, as a last resort, if there are no other options, we may use specific scripts for this. Okay, so also some work that it's in progress. It is improving the Nexus file generation from Sardana to be able to comply with application definitions. And also, we are integrating Bliss data into Sardana, so we may use the same publication to Redis from Bliss data for this. Okay, when we have the data metadata here, we have another step before going to the data portal, which is made by the scientific data management group, where they have the Redis listener, and then they check the stream that arrived. If there is an elog message, they go directly to the elogbook database. Otherwise, if there's a data set, they are processing this data set. In this case, it is extracting the metadata that to create an XML file for ICAT, and it is published to the database. But if we don't have a Nexus file from the beamline directly, in this step, they may create a Nexus file, application definition compliant, and also in this step, we are getting information from other external sources as the user office in this case. Okay. We implemented also a few procedures for dataset validators, especially now at the beginning that we are starting to use this, to check that the metadata is properly ingested in the database, and some means to edit this in case it's necessary. Okay, so this would be the whole picture from the beamline to the data portal. And here I show you the full architecture of how we implemented this. I highlighted the parts that I mentioned during this talk. So the ICAD core, the ICAD Plus from the SRF that it is providing all the front ends like the data portal, so the users can access through this. When we are collecting the data, there is the ingester here, the ICAD DB is here, so it's architecture similar that the one that is adopted in the SRF as we are collaborating with them. So I will finish with some remarks. After several iterations that we have in the design and how to implement the data catalog, especially from the data, how to extract the data from the beamline to the catalog, we managed to implement it, to integrate it successfully in a first beamline, and they are happy about this. Half of the beamlines at Alba are being testing right now, so we are already publishing to ICAD database, to a testing database, and they are close to moving production, so we hope that by the end of this year or beginning of the next one, it will be possible. It is a slower process that we were expecting because there are these organizational challenges that I mentioned, but also operational constraints, because every time that we want to test, we wanted to test this with real users, so we are waiting for an experiment, which we see that everything is being published well, so it is slow. And and then some of the current working are some improvements that we already identified. We are trying to reduce the processing layer, the SDM processing layer, as I mentioned. For example, in the case of MX Cube, that we will ingest directly to the data catalog. So maybe we can do this in other techniques as well. Improving the Nexus file. Well, these I already told a little bit about this. And then improving the front end and the data catalog for processing, reprocessing, and to add micro front ends for other techniques, as it was also mentioned by the talk from SRF. Okay, well, to finish, I would like to thank the people that has been involved in this work from the different groups, also the scientists and the people from the user office, because we spoke a lot with them, and also the people from the SRF of the data portal, because they help a lot in the implementation in our site. And that will be it. Thank you very much.
Thank you very much, Oriol. Very interesting to see this initiative having the scientists on board since the beginning. Is there any question? If not, so thanks again to Oriol, and we'll